on partial fractions, and so here I'll kind of go through what I proposed to do. So we had the integral of x squared plus 2 divided by x minus 1, 2x minus 8, and x plus 2 dx. Now, this has a 2 that's in this factor, so we could factor that out, and we would get 1/2 the integral of x squared plus 2 over x minus 1, x minus 4, and x plus 2 dx. Now, the partial fraction technique says if we got a fraction that looks like this x squared plus 2 over x minus 1 and x minus 4 and x plus 2 could have come from something over x minus 1 plus something over x minus 4 plus something over x plus 2, and then somebody tried to get a common denominator, and so it's all 3 multiplied, and to get that. So, what could be the numerators here? Well, if this is a linear factor, and by that I mean a factor that if you were to graph y equals it, makes a line, so it's a degree 1, has x to the 1. This would be a linear factor, this is a linear factor, this is a linear factor. Then we can say, well, it's got to be some number and some other number and some other number. So now we're going to figure out what the A, B, and C are. Now, we want this to be identically equal to this. For every x, what we get out of here, we get the same thing out of here, not just for some x's. So sometimes that's indicated by saying identically equal with a triple equal sign. So we'll make it identically equal. Then if we were to try to add these together, we would have to get a common denominator, which means we'd have to multiply this first one by, let me get a different color here. We'd have to multiply the first one by these two multiplied. So I'm going to write here what we would have to multiply the numerator and the denominator by, but I'm just going to show the numerator part. That's what I'm going to be most concerned about. So it'd be these two multiplied, which would be x squared plus 2x minus 4x, which is minus 2x, and then minus 4 times the 2 is minus 8. This one I'd have to multiply by both of those, numerator and denominator. And I'm just going to be concerned about the numerator here, so that would be x squared plus 2x minus an x, which is plus 1x, and minus 1 times plus 2 is minus 2. That's what I'd have to multiply the numerator and denominator to get a common denominator. And then this one I'd have to multiply by these two, which would be x squared minus 4x minus 1x minus 5x plus 4. And now, if these are going to be identically equal, the number of x squareds I have in this numerator has to equal the number of x squareds I have in here. The number of x's have to equal the number of x's, and the number of the constants have to equal. So I'm going to look at the x squareds first. And here I have 1x squared. So over here I have to have 1x squared. Right now I have ax squareds and bx squareds and cx squared, so a plus b plus c must add to be 1. And then the x's have to be the same. Now over here I don't have any x terms. I have an x squared term and a constant. I have no x term, so I have to have no x's coming out of here. So all the x's from here have to cancel. So I have a times minus 2x, or minus 2a number of x's. And in here I have plus 1b number of x's. And here I have minus 5c worth of x's. And so those expressions have to add up to 0 because I have to have no x's. And then the constant has to also work. And the constant here is 2. So from here, all the constants have to come out to be 2. Well, I got negative 8 times a, and I have negative 2 times b, and I have 4 times c. Okay, now this is a system of equations that I have to solve for a, b, and c. And there are lots of different ways to do this one: linear combination, substitution, blah, blah, blah. But I like to just pull out the calculator and do matrices, and that's what I've been showing in class. So if you haven't been in class, here we go. So I'm going to pull out my calculator, turn it on, and I'm going to go clear the screen, and I'm going to choose matrix, which I'll move this up here. I hate it when I get these reflections, but okay, that's the best I can. Now let's see. I'll do it over here. I'm going to find the matrix key on this calculator. It's here, and some calculators it's over here. It's right here on the blue, so I go to second matrix. And then it allows me to edit them, and then also to have the names of them. So I want to edit. So I'm going to go over to edit, and I'm going to make A be my coefficient matrix. Now, by that I mean how many A's, B's, and C's are in this one, how many A's, B's, and C's are in this one, and how many A's, B's, and C's in this one. And I have to do them in that order, all organized and everything. And that's a 3 by 3. Now I can change this to more like a 4 by 3, and you'll see I'll have 4 lines and 3 columns. But I want 3 by 3 because this will be 3 coefficients for every one of the 3 equations. So it's going to be 3, enter, 3, enter, and I'm going to put in 1a in the first equation. There's 1b in that equation, enter, and 1c, so I press that 1, enter, and then I'm going to put in minus 2, 1, negative 5, and in the next line it's negative 8, negative 2, 4, and I've got a in. Now, I'm going to enter these into B. So I'm going to go second matrix, edit, B, enter, and this is going to have 3 rows, 1 column, so it's a 3, enter, 1, enter, and I'm going to put in 1, enter, 0, enter, 2, enter. Okay, now where some students forget is to quit. So that second mode, quit. So I'm back on my home screen. If you got stuff in there, you can clear it, whatever you want. Now let's make sure we got A in. So I'm going to go second matrix, and I'm going to choose the name A, and I'm going to press enter, and it should look like what I have here: 1, 1, 1, minus 2, 1, minus 5, and minus 8, minus 2, 4. And that matches up. We can check our B, second matrix, go down to the name B, and press enter, and we get 1, 0, 2. Now, just a quick explanation. What I've just done is rewritten it in a matrix form. You don't need to know exactly how this all works. 1, 1, 1, minus 2, 1, minus 5, and minus 8, minus 2, 4. And matrix multiplication is kind of weird, but it would be A, B, and C. My unknowns would equal the 1, 0, 2 matrix. So it's kind of like an algebra 1 equation. A number times an unknown equals a number. To solve it, I have to undo this number. And undo is an inverse. Undoing is an inverse function. And so I need the inverse of this equation, 1, 1, or this matrix. Minus 2, 1, negative 5, and 8, negative 8, negative 2, 4, and that times this should get rid of this and say ABC is going to equal what I get on this side. Well, if I multiply by this on this side, I have to multiply on this side by the same thing. I called this A, so this would be A inverse, and I called this B, so I want to type in A inverse B, and it has to be in that order. It can't be B A inverse. So in my calculator, I'm going to type A, second matrix, name A, inverse, I'm going to get by pushing this button. And it'll do more than just the reciprocal that it does on regular numbers. It'll do the inverse of this matrix, which is kind of really cool. That's not an easy thing to do if you don't know how to do linear algebra. And even if you know, it's a little tough. We want to do A inverse times B. So I'm going to get second matrix B, enter, and if I press enter, it tells me what the A, B, and C need to be. And you can see they're in a decimal. You probably recognize that as minus 1/3, 1, and 1/3. But I can also go math, change it to a fraction, enter, enter, and it'll say those. So this problem, remember those, I'll write them down here. A is minus 1/3, B is 1, and C is 1/3. So this problem, actually this part, can be changed to the integral of this thing with what minus 1/3 there, 1 there, and 1/3 there. So now I can split this integral up into these three partial fractions. So I have the 1/2, and then I have the integral, I'll write all this out here, the integral of A, let's see, that's minus 1/3, which I could pull out, minus 1/3, and then that would just leave a 1 there, 1 over x minus 1 dx, plus b was 1, so if I pull it out, it still looks like 1 over x minus 4 dx, plus, and I can pull 1/3 out of this one. First one I had to pull out a minus 1/3. I've got to make sure, yeah, minus is in there. It's not easy to see. This one I'm going to pull out a positive 1/3. Antiderivative integral of 1 over x plus 2 dx. Now, this is a linear factor, and since there's no coefficient on the x, this is really easy to do. Because if I let u equal x minus 1, du would be equal to dx. So I'd have 1 over u du. And 1 over u is, antiderivative is ln u. So I have 1/2 times negative 1/3, which is negative 1/6 ln of x minus 1. And that's that one. Plus 1/2 times this, so I got 1/2 times ln of, if I let u be that, then du equals dx, so I get 1 over u, which is ln of x minus 4, ln of u. If I let u be that, that becomes 1 plus 1/3 ln of x plus 2 plus c. Okay. Oh, and on this one I forgot to take it times 1/2, so that's 1/6. There we go. So I'm checking my answer here, make sure I didn't make any other mistakes. Yep, that's the correct answer for that one. Okay. So that's how we can use partial fractions to break up something that looks pretty ugly into simpler integrals that work out for us. All right, so we're going to do partial fractions again. The next one I'm going to do is the antiderivative of 18 over x plus 3 and x squared plus 9. Now, this is a quadratic factor. If you graph it, it makes a parabola. This is a linear factor. If you were to graph y equals x plus 3, you get a line. So linear factors, you put a single constant like a over it. But quadratic factors, you have to deal with a little differently, unless that factors. Now, does x squared plus 9 factor? I believe not. So this 18 over x plus 3, x squared plus 9 has a linear factor, so we just put a constant over it. We can use a, could use b, could use c, could use any letter, x plus 3, but on a non-factorable quadratic factor like this, we have to do a 1 degree less. See, this is a linear, it's degree 1, that has degree 0. So if we got a quadratic factor like x squared plus 9, we do a linear factor, which would be some number of x's plus a constant. So that's what we write as a linear factor over a quadratic denominator. Now, if we were to add these two, we'd have to get a common denominator. So this fraction would have to be multiplied by x squared plus 9, numerator and denominator. I'm just going to show the numerator part there for just don't hold my attention. And this one would have to be multiplied by that factor, which is x plus 3, both numerator and denominator. And I'm just going to show that there temporarily because we're going to jump right into, okay, over here I'm going to get some x squareds, I'm going to get some x's, and some constants over here. So I'm going to get some x squareds, some x's, and a constant. So I'm going to be identically equal, the number of x squareds I have here have to equal the number of x squareds I have here. I have no x squareds in the numerator here, so 0 has to equal, I got a of them here, and I'm going to get b of them there. So I'm going to get a plus b, ax squareds plus bx squareds are going to have to come out to be 0. And x's, over here, again, I have no x's. So on this side, all my x's have to cancel out. Well, a times x squared is not x's, that's x squareds. And a times 9 is a constant. Here I have bx times x, that's x squared. But I have bx times 3, so I have 3 bx's. And I don't put the x because I know I'm working with x's. And then, do I have any more x's? I think if I multiply these two, I get cx's. So 3b plus c has to equal 0 because there's no x's here. And that's how many x's I get out of this. And then I look at the constant. I have 18. So over here, the constant have to add up to 18. Well, a times 9 would be a constant, because a is a constant. So I got 9 a's. And let's see, do I get any b constants? No, because b's times x. So b will never be a constant. If I take it times this, I get bx squared. This times this is 3bx. Those are not constants. Then I have c times x. That's not constant, but c times 3 is. So I got plus 3c. So here's what I need to solve for a, b, and c. And you can do other methods, but I'm going to use my calculator. I'm going to say there's 1a, there's 1b, and there's no c's. No a's, 3 b's, and 1 c. 9 a's, no b's, and 3 c's. So you can see that I was planning ahead and writing my a's first, my b's, and my c's, keeping them all lined up so that they'll work in the matrix. So now I'm going to pull out my calculator, and I'm going to change my a by going second, matrix, edit, a, and it's still a 3 by 3, and that's going to be 1, 1, 0, 1, enter, 1, enter, 0, enter, and then it's 0, 3, 1, 0, 3, 1, and then it's 9, 0, 3, 9, 0, 3. Now I'm going to put in my b, which is just these, what was in the numerator here. So I'm going to go second, matrix, edit, go down to b, press enter, and it's a 3 by 1, and I'm going to put in 0, 0, 18. Okay, so now I can quit, and now I can go matrix A inverse matrix B, and press enter, and I have my answers for my A, B, and C. So the A was 1, the B was -1, and the C is 3. So set that aside. So this integral becomes the antiderivative, or the integral of 1 over x plus 3 plus -1 x plus 3 c bx plus c, -1 x plus 3, over x squared plus 9 dx. Okay, now this one is, if I let u be the x plus 3, du would be dx, and so I get 1 over u du. It's just ln of x plus 3. This one is not so nice. If we let u be x squared plus 9, then du would equal 2x dx, and then I'd get du over 2x is dx. So this one would change to the integral of -x plus 3 over u, and du would be over 2x. Okay? And what's going to happen with this? So we got ln of x plus 3 plus. Now, I could split this up into two integrals, this and that. So it'd be negative the integral of x over u du over 2x. The x's cancel. The 2 would come out as a half of and 1 over u integrated be ln of u, and u was this, so I'd get, I'll have this still, ln of absolute value of x plus 3. Then I'd have minus the ln of u, which is x squared plus 9 and a half. So I'll make that a half and then put a minus. So I got this minus 1/2 ln this. But then I still have this integral of 3 over u du over 2x. And I still have to figure that one out. Now, what can I do about that? Well, that one is not quite so easy. So I'm going to go back, undo this u substitution that I did, and I'm going to call this, the second part came from the 3 over this stuff. The minus 1 over this created this integral, but this didn't. So I'm going to go back to what it was, the integral of 3 over x squared plus 9 dx. So what I probably should have done, so I didn't confuse you, is split this up into the minus 1x over this, and then 3 over this. The minus 1 over x is what I got out of this part. But I still have this to do. And this is a little bit tricky to see. We know the antiderivative of 1 over x squared plus 1. But what do I do with it if it's a plus 9? Can I make it look something like this? Well, I'm going to pull the 3 out of this. That makes it 1 over. And I'm going to pull a 9 out of this. That would make this be 1/9 x squared plus 1. Now what am I going to do? Well, 1/9 is 1/3 squared. So I have a 1/3 on the outside. Antiderivative of 1 over 1/3 x squared plus 1 dx. Now, that's starting to look like an x squared plus 1, which is an arctangent, but it's got that third in there. How do I deal with that? Well, if I let u equal 1/3 x, du would equal 1/3 dx, and so 3 du equals dx. So this would become 1/3 antiderivative of 1 over u squared plus 1, and my dx is 3 du. And this 3 would cancel this 3, so I have the integral of that, which is just arctangent of u, and u was 1/3 x, so this last part here becomes, so I have this minus this plus arctangent of 1/3 x plus c. And so here is the final answer to this antiderivative. That part there, this one, you got a quadratic factor in the denominator. Integration is a lot harder. And you're going to see that again on another one. Well, let's do one that's not quite so hard. Let's go to the next one I want to go through, which looks almost like the last one. It says the antiderivative of 18 over, they had x plus 3 and x squared minus 9. The one we just did was x squared plus 9. This is x squared minus 9. And I'm doing this one just to show you how much different it is if that quadratic factor actually factors. Okay, so we're going to try to break this into partial fractions. And I could factor out an 18 and make it 1, but I'll just leave the 18 there. X plus 3, and this factors to x plus 3 and x minus 3. So, we want to make something identically equal, and you have to kind of know ahead of time how to set this up. Well, we got a single linear factor here of x minus 3, so we can put an a over it. But this other linear factor happens twice. It's squared. And when that happens, you have to put it once with a constant over it. And then you have to put it, not just it again, but it squared with a constant over it. If it appeared 3 times, if it was x plus 3, x plus 3, x plus 3, and x minus 3, I'd do a over x minus 3, b over x plus 3, c over x plus 3 squared, and d over x plus 3 to the third. Messy. I don't want to get into that. Okay, just like we've done before, what would we have to multiply to get a common denominator? Well, this one would need an x plus 3 quantity squared. So x plus 3 times x plus 3, hopefully you know that's x squared plus 6x plus 9. You can write down x plus 3 times x plus 3, 2 parentheses, FOIL it out, you should get that. This one is going to need another x plus 3, because this has 2 of them, and it needs an x minus 3. And hopefully you know an x minus 3 times an x plus 3 was x squared minus 9. And this one has an x plus 3, has two x plus 3s, it just doesn't have the x minus 9. X minus 3. Okay, so looks like the highest power of x we're going to get is x squared. So we're going to say, figure out an equation with the x squareds and with the x's and with the constant. So with the x squareds, there's none over here, so I'm going to start with 0 equals. Over here I have ax squareds, here I have plus bx squareds, and here I have none. So that's my first equation. My second equation, dealing with the x's, again, there's no x's here either. There's no x squareds and there's no x's. Over here I get 6a worth of x's. Here I get no x's, and here I get cx's. So you notice I don't put the x's. Then I'm leaving space for the b. I know we're talking about x's, so I just leave the x's out. And now the constants. And the constant is the only thing I have here. 18 has to equal 9a minus 9b and minus 3c. Okay, so again, I'm going to pull out my calculator, do matrices to solve this. So I got to go to matrix and edit A. It's still a 3 by 3, and my first row is going to be 1, 1, 0. Already have that. My next row is going to be 6, 0, 1. 6, enter, 0, enter, 1, enter. And my last row is going to be 9, enter, negative 9, enter, and negative 3, enter. And then my constants. So second, matrix, edit, B, and 0018, same as what I had last time because that's what I had last time, was an 18 only. So quit, and I'm going to do matrix A inverse B, which is what I did last time, so all I have to do is hit enter, and it tells me my A is 1/2, my B is -1/2, and my C is -3. A is 1/2, B is -1/2, and C was -3. So this turns into the integral of this plus this plus this dx, and with 1/2 up here, I'm going to get 1/2 the integral of 1 over x plus minus 3 dx, which is ln of x minus 3. For this one, it's going to be minus 1/2 the integral of 1 over x plus 3, which is ln x plus 3. And this one is a quadratic. Okay, so we're going to have a little bit more trouble. We're going to have minus 3, the antiderivative of 1 over x plus 3 squared dx. So if we let u equal the x plus 3 on this one, this is going to be not as bad as some of the other ones here. Then we're going to get du equals dx, and this would become the integral minus 3 antiderivative of 1 over u squared du. Well, 1 over u squared is u to the minus 2. If I integrate that, I add 1, I get minus 1, and divide by minus 1. So it'll become a plus 3 times 1 over u, and u is x plus 3, and that would be it, plus c, because if I add 1 to this, it becomes u to the minus 1, which is 1 over u, but it becomes also divided by minus 1, so it's minus 1 over u. So minus 3 times minus 1 over u is plus 3 over x plus 3. So that plus that plus that is the antiderivative of that. Okay, and the next one that I want to do will be this one. I'm going to do the antiderivative of 3x minus 9 over x minus 1 and x plus 2 squared dx. And this one's going to be fairly straightforward. It's very similar to this last one. It had a repeated factor, so a factor squared, and then another factor. So it's going to set up similarly. We just have a different kind of numerator. So we're going to get 3x minus 9 over x minus 1 and x plus 2 squared, and we're going to have to do a over the linear factor plus b over, this is not a quadratic, this is a linear factor squared, so b over x plus 2 and c over the x plus 2 squared, because it's a repeating factor. So solving this, I would need to multiply this one by x plus 2 quantity squared. That is x squared plus 4x plus 4 if I take x plus 2 times x plus 2 and FOIL it out. This one needs to be multiplied by another x plus 2 and an x minus 1, so these two. So it's going to be x squared Plus 2x and minus 1x is plus x. And minus 1 plus 2, times plus 2 is minus 2. And for the final one, all I need to multiply it by is an x minus 1. So let's do our equations. I'm going to get x squared, so I'm going to get some x's, and I'm going to get a constant. My x squareds, none here, a here, b there, and none there. My x's, I have 3. Over here I have 4a. Here I have b. And here I have c. And the constant, negative 9. And here I have 4a minus 2b and minus c. Okay, and there's lots of ways to solve this. Once again, I'm going to go straight to my calculator and go second matrix, edit, A, 3 by 3, 1, 1, 0. I already have that. 4, 1, 1. 4, enter, 1, 1, enter. Then 4 minus 2 minus 1. 4, negative 2, negative, and negative 1, enter. Okay, have that right. Second matrix, edit, B, and I want 0, 3, and negative 9. 0, 3, negative 9. Didn't hit enter on it, so go back up. 0, 3, negative 9. Okay, second quit. I want to do A versus B. That's what I did last time, so I press enter. If I don't like the looks of those, I can go second math and see what they are in fractions. Oh, not second math, but math. Enter, enter. Negative 2/3, 2/3, and 5. Let me check and make sure I got that right. I didn't. Yes, I did. Yes, I did. That's correct. So, this becomes the integral of these dx. The negative 2/3 will pull out, so I'll get negative 2/3, just a linear factor, so it's ln of x minus 1. If there was a 2, I'd get a 2 in the denominator or something, but right now I'm not getting anything because there's no on the x. And this is going to be plus 2/3 ln of absolute value of x plus 2. And then I have plus 5 antiderivative of x plus 2 squared dx. Now to do that last part, I'm going to let u be the 2x, x plus 2 du equals dx. So this becomes the antiderivative of 1 over u squared du with a 5 out in front. And the antiderivative of this is u to the minus 2, antiderivative, add 1. It's u to the minus 1 over minus 1, which is minus 1 over u. So this last one would change to 5 times 1 over and minus 1 over u, and that's x plus 2, and then plus c. So this, and those. Now the last one that gets the messiest. I'm going to start with a whole new sheet of paper on this one. The last one I did in class. So we have the antiderivative of 4 minus x over x times x squared plus 2 squared. So now I have a quadratic factor that happens twice. Ugh, 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 ugh. So I have 4 or minus x over x times x squared plus 2 squared, which means I have a linear factor, just the x. I can put a over it. Then I have a quadratic factor. Remember that the quadratic factor has to have a linear factor in the numerator. So it's bx plus c over x squared plus 2. But then I also have to do, since it's a double, it happens twice, it's multiplied by itself, it's squared. I have to do it squared, x squared plus 2 quantity squared with another linear factor, dx plus e. So we have 5 letters to solve for on this one. So a needs to be multiplied by x squared plus 2 squared twice. So x squared plus 2 times x squared plus 2. So ignoring that, I would do like this times this, ignoring that. So that's x to the 4th. 2x squared, that's 4 plus 4x squared. And then 2 times 2 is 4 plus 4. X squared plus 4x squared plus 4. X to the 4th, I should say. This one, I need to multiply by one more of these, because they're squared, and by an x. So I got to multiply by x cubed plus 2x. And this linear factor needs to be multiplied by, it's got both of these, so all it needs is an x. So now I'm ready to solve for my a, b, c, d, and e, and my highest power of x is x to the 4th. So I have to look at x to the 4th, then x to the 3rd, then x to the 2nd, then x to the 1st, and then the constant. So x to the 4th, none here. A here, and b here, and no more x to the 4th, because this would be 2bx squared, and cx to the 3rd, and dx squared. There's no more x to the 4th. So a plus b has to be 0. There's no x to the 3rd, so I start with 0, equal, over here, no x to the 3rds come out of this. Bx times 2x is x squared, but c times x to the 3rd, so c x to the 3rds, and out of here, there's no x to the 3rds. So it says here, c has to be 0. So that's nice. X squareds. We've got some x squareds here, 4 of them, times a. So, and over here, none. So none equals 4a. Any x squareds out of here? Yes, bx times 2x, so there's 2b of them. And c times x3, c times x, nope, no squares there, and no other squares there. And dx squared, so that'd be plus d. Now x's. No x's out of this. Bx times, those have x's, so the lowest would be bx squared. But I do get c times 2x, which is, x's here is -1, equals 2c, and no d's, plus an e. And finally, the constant, 4 on this side. I got 4a, and there's x's in both of these, so there's no way that there's just going to be a constant here, and this has got an x times all of, so there's nothing. So I'm done. Now this one happens to be bare enough that it's pretty easy to see what's going on here. If 4 a's have to equal 4, a must equal 1. And if a plus b equals 0, b must equal negative 1. And we know that c is already 0. And d is 4 times 1 plus 2 times negative 1. So 4 minus 2 is 2, plus d is 0. So d must be negative 2. And e, since c is 0, e must be negative 1. So I'm going to jump down because this one's messy enough. This integral, this antiderivative, will become the antiderivative of 1 over x dx times a, which is 1, plus the antiderivative, so b was negative 1, c is 0, so we got negative x over x squared plus 2 dx. And then we have plus. D is minus 2, e is minus 1, so we have the antiderivative of minus 2x minus 1 over x squared plus 2 quantity squared dx. This integral are going to be easy. This one is not easy. It's partially easy. So this one is going to be ln absolute value of x. This one we're going to do a u sub for the x squared plus 2 du equals 2x dx. So we'll get integral of minus x over u, and dx will be du over 2x, du over 2x. The x's cancel, so we get minus 1/2 ln u. ln absolute value of x squared plus 2. That one was not bad. And that one's not bad. This one, if we split this up, we get the, since it's addition in the numerator, we can split it according to that. So we get minus 2x over x squared plus 2 squared dx, and we'd get plus antiderivative of minus 1 over x squared plus 2 quantity squared dx. This one's not bad. We'll do the same u sub here, so we get the same dx. So this becomes the antiderivative of negative 2x over u squared, and dx is du over 2x. So the 2x's cancel, and we get negative antiderivative of u to the minus 2 du. And so the minus 2, we add 1, we get minus 1, and divide by minus 1, which will change that to plus. So we get plus 1 over u, which was x squared plus 2. And we're through that one. Halfway through this. This one is not easy. Hold on to your hats. Here we go. This, if it was x squared plus 1, it would almost be an arctangent thing. So, it's not, but I can think of this. Now I'm going to come down here. I'm going to think of this as x squared plus the square root of 2 squared, which would come off of a triangle if I put x here and square root of 2 here. The hypotenuse would be the square root of x squared plus square root of 2 squared, which is 2. So my substitution is going to be a theta. And the tangent of theta is going to be x over the square root of 2. That's going to be my substitution, believe it or not. We're going to learn more about this tomorrow and Monday and Tuesday. But for right now, hang on to your hats. So then, if I take the derivative of both sides to figure out what I'm going to replace dx with, the derivative of this would be 1 over the square root of 2 dx. The derivative of tangent of theta is secant squared theta d theta. So to replace dx, I'm going to put the square root of 2 over here and not there. And now I'm going to go to my problem, and I'm going to say I have the antiderivative of minus 1 over, well, that denominator looks like this, but it would be, this is the square root, and it's actually squared. So I'd have to take the square root of x squared plus 2 to the 4th power to unsquare root that and then square it. Because this is to the half power, so this to the half power to the 4th power makes the power of 2, which is what that is. So I need to have an expression for that. And that would be, if I do this over that, that's a hypotenuse over adjacent, that's the secant. So the square root of x squared plus 2 over the square root of 2 is the secant of theta. And I need it to the 4th, this thing to the 4th to make a squared. So I would take this to the 4th power and this to the 4th power, and I get secant to the 4th of theta equals x squared plus 2 squared, and the denominator would be square root of 2 times square root of 2 times square root of 2 times square root of 2, which is 4. So if I multiply both sides by 4, that denominator becomes 4 secant to the 4th theta, and my dx is square root of 2 secant squared theta d theta. Well, the fun's not over yet. We do get to cancel 2 of the secant squareds. So they cancel, and I left with the secant squared in the denominator, which is the same as cosine squared theta in the numerator, and the square root of 2 and the 4 pull out, and the minus, so I get minus square root of 2 over 4 antiderivative of cosine squared theta d theta. And that looks like it would be easy to integrate. Doing u sub or something like that? No, it's not easy. You have to pull out some old trig identities that you might remember or maybe not. And one trig identity is this one. Okay, wait a minute, my computer's acting up here. Okay, I'm still recording. Okay. One you might remember was the cosine of 2 theta is cosine squared theta minus sine squared theta. And if you make the sine squared 1 minus cosine squared, you get 2 cosine squared theta minus 1. So if I solve for cosine squared, which is what I'm trying to find the antiderivative of, I get cosine of 2 theta plus 1 divided by 2. That's what cosine squared theta is equal to. So if I can integrate this, that'll be what that integrates to. So this integral becomes minus the square root of 2 over 4, antiderivative of 1/2. It's 1/2 on both of them, so I'll just take that out, of cosine of 2 theta plus 1 plus 1. This can be split up. The antiderivative of cosine is sine of 2 theta, but that, if I took the derivative, I'd get a half, or I'd get a 2, so I have to put a half in front of it. And then the antiderivative of 1 is theta, and both of these are going to be times negative square root of 2 over 8. Now we got to get back to x's. Okay. So theta, going back to here, is the arctangent of this. If I take the arctangent of both sides, it undoes the tangent. So my final answer for this one, for this part, let's see, we got this one, and the 2 minus 2x over it was this. And now we get, for this part, we get minus square root of 2. Oops. So you can see it, minus square root of 2 over 8 over 16 times 2 sine of 2 times the arctangent of x over the square root of 2 plus arctangent of x over the square root of 2. And this is times both of these plus c. Now, the sine of the twice that angle, we can also use some double angle formulas and simplify that a little bit. But this problem, when you get to stuff like this, we get messy problems. Even though partial fraction splits up some of it, you could still run into some nasty integration stuff. This is called trig substitution stuff, and we're going to learn more about that soon. Enjoy.